if the chances may not the same. So our second algorithm is to generate 3 evenly distributed real number between 1 and 3, rather than an integer number between 1 and 3. When the number is 1, we print out rock. When the number is 2, we print out the paper. When the number is 3, we print out the scissors. So this is the flow diagram of what we want to do a bit later in a program. We try to generate a random number. We multiply this random number by 3.0. We'll get a value between 0 and some numbers less than 3. After that, if I take the integral part of max.random times 3 and integral part, I will get the value 0, 1, or 2. If I plus 1, I will get the value either 1 or 2 or 3. Right? So now I have 3 possible cases. So if x equal to 1, I want to output rock, followed by a break, I come out. If x equal to 2, I want to print out the paper, followed by a break, I come to here. If x equal to 3, I output the scissors. After that, I will come to here, continue to do some other tasks outside the case, outside the switch statement. Now let's look at the design. The design is very simple. We randomly generate a number x in between 0 and 1. As I said just now, if you multiply x by 3.0, you will get from 0 up to a number less than 3. If you take the integer part of x times 3.0, you will get 3 possible integers, 0, 1, and 2. If you plus 1, you will get a random number in between 1, 2, and 3. That will be 3 integers, 1, 2, and 3. So therefore, assume that this integer value is stored in a variable called hen. Now I can switch off the hen. If the value of the hen is equal to 1, we go to case number 1. We system.out.println the word rock. Followed by the break, we come out from the switch body, but still inside the main method. So if the value given to the hen is equal to 2, we go to the case number 2, we print out the word paper, followed by a break, we come out to the main method. Otherwise, case number 3, we print out the scissors. So you can see that for case number 3, we don't need a break. Immediately after the printing, we can exit from the switch statement. Next example. Suppose I define enum day consists of Sunday, Monday, Tuesday, Wednesday up to Saturday. I try to get an integer during the runtime. I try to store it in the day. Now I say switch the day. If case equal to 1, no problem. I say Monday is bad, right? Day dot Monday is bad. Day to day in the printing you will have Monday is bad. After that, if the day is equal to 5, your system dot out dot println day dot Friday plus is better. Day to day Friday is better. Followed by a break, you come out. After that, if the day is either equal to 6 or 7, I print out weekend are best. Followed by a break, I come out. Now if the day is greater than 7, I system.out.println, please enter a number less than 7. Otherwise, I print out weekdays are so-so, right? So these are an example for the switch statement. So now you can see that two cases share the same statement, share a common statement. Weekend are best when the day is 6 or 7. Next example, asking you to find where is the error, but the error is rather than the logical error, and it's not the syntax error. Suppose I try to get a number during the runtime. I say case 0, system.out.print line number is 0, no problem. I say if the number is equal to 1, case number 1, system.out.print line number is 1. But there is no break after the case 1. In that case, number is 2 is also printed out. So for the number equal to 1, number is 1 and number is 2 are printed out. But if the number is equal to 2, we'll come to the case number 2, number is 2 is printed out, followed by a break. So the default system.out.print line number is not in range. So in that case, we display a message. So if you wanted to update the logical error after the case 1, you may want to put a break so that when the number is equal to 1, you print out the number is 1. And when the number is 2, you print out the number is 2. So a break if you want to. So we have completed the selection structures. So we'll see one detailed example on how to use the switch statement. After this example, your lab number 4 is out. Now, this was our previous example. Still remember that we defined a class to describe. We define a class to describe my character. My character has a CH, a character, T, a type. Type is either letter, digit, or other. I also try to include one more type, which is the space. After that, I have a default constructor. If this is the space, the type is other. I can also say the type is a space. It's a type dot the space, more relevant. Otherwise, I initialize the CH and the T. This dot CH is equal to CH. This dot T is equal to T. This dot CH refer to the intern variable CH. This dot T refer to the intern variable T. CH on the right hand side of the equal sign refer to the parameter. T on the right hand side of the equal sign also refer to the argument. Now we also have the accessor method to get the character, to get the type. We also have the set info method to set the current intern variables to the argument. Now let's see what we want to do for this example. Now in this example, I want to read in a character. I said that if this character is a letter, I may want to ask, is it a vowel? If this character is a digit, I may want to ask, is it odd or even? If this character is another symbol, is it a space or non-space symbol? So we are going to see the detail of the design. So just now I said that probably here I can change it to space, more relevant. Now inside the main method, so far I do nothing, right? So far I do nothing. So let's look at our first case. Our first step, of course, is to read a character. So a system dot out dot print enter a character. So I can say CH is equal to input dot next line. Last lesson we said that if you want to read a space, you cannot use the next, you must use next line. After that we say character at 0. Now what shall I do? I want to test the character type. So I can say if CH is greater or equal to uppercase A and CH is smaller or equal to uppercase letter Z. Two possible cases. Or CH is smaller or equal to lowercase a and CH is smaller or equal, greater or equal to, smaller or equal to, sorry. So the first, this one is smaller, greater or equal to. And this is smaller or equal to lowercase letter Z. Now, I can say the type T is equal to type dot the letter. Now, I want to test, is it a vowel? So I continue, I will say if CH is equal to uppercase A or CH equal lowercase a or, oh sorry, I want to use the switch statement. I make a mistake. So I can use the switcher statement, switcher of CH. Now I will say case, uppercase A, case, lowercase a, case, uppercase E, case, lowercase e, case, uppercase I, case, lowercase I, case, uppercase O, case, lowercase o, and case, uppercase U, case, lowercase u. Okay? So now I can see system dot out dot plain line. I say it is a vowel. Right? I'm satisfied. Great. I exit from the switcher statement. Now I have the default case. I can say system dot out dot plain line. It is not a vowel. I close. So I don't need to have the break. So I close the else tab, right? So you can see that. If I make it bigger, it doesn't matter to the other side. So therefore you can see that if a CH equal to character to the uppercase letter or the lowercase letter, I can have a switch statement to determine whether it is a vowel or it is not a vowel. Now the next case. Else, I will say if a CH is greater or equal to character 0 and CH is smaller or equal to character 9. So I can say the type is equal to type dot the digit. Now I want to check whether the CH is equal to even or odd digit. I use the switcher statement again of CH. I can say case 0, case 2, case 4, case 6, case 8. So I system dot out dot plain line. It is even. Okay, followed by the break. Default system dot out dot plain line. It is odd. Now I close the switch. I close the if. Else, no other alternative. the type T is equal to type dot the other. Now I can use the switch statement again. Switch of a CH. I can say case, a space. So I system dot out dot pin line. It is a space. So followed by a break. Default. I system dot out dot pin line. It is a non-space symbol. I close the switch, I close the else. Now I construct an object of my character. So I can define my character. MC is equal to new my character. So I pass in the character CH. I also pass in the type. Now I print, I have a method to print the info. So I can say MC dot print info. Okay, I save. So I jump. So I Java test switch number 1 dot Java. Oh, sorry, short of one bracket. Save. So Java. My character. So I Java test switch number 1. I enter U. It is a vowel, right? Character is U. It is a letter. So next I enter the Y. It is not a vowel, it is a letter. So I enter a character digit 6. It is the even, character is 6. Now I enter the 5. It is odd, character is character 5. It is a digit. Now I enter an ampersand. So it is a non-space symbol. Character is ampersand. It is other. Now I enter a space. It is a space. Character is a space. It is other. Now I save as 1A. Still remember last lesson we said that if I declare a variable n, I say n is equal to ch minus the character 0. Still remember that? If a ch minus a character 0, we'll get the corresponding integer digit. If a ch is equal to character 8 minus the character 0, we have integer 8. Character 9 minus the character 0, we have integer 9. Right? Now, how to apply that to the switch statement? I can update that. I can say n percentage 2. Now n percentage 2, only two possible values. Case 0 or case 1. So therefore, if this is the n percentage 2 is either 0 or 1. So therefore I can say case 0, system.out.println, it is even. Default system.out.println it is odd, right? Others remain unchanged. So now I save. So in Java 1A, I haven't changed to 1A yet. So I save. So Java 1A, in Java 1A. So I need to test for integer, right? No problem. I save as version number 2. Now, so this is the switch statement. Now, I read in a character. So we wish to divide the character set into 3 types. So just now you can see that the first type is the letter, the second type is the digit, and the third type is other. One of them, and then for each type, we wish to do further analysis. Okay? So this is my version number 2. So I change it to version number 2 first. Now, my design is very simple. I throw away this. I throw away this. And I throw away this. So now you can see that we divide our characters into 3 types, either letter or digit or other. Now if the if statement has only one statement, you don't need the braces, you don't need to use the compound statement notation. So we make it very neat. We make it very neat. So you can see that now my design is very neat. Now for each type, I want to do some further analysis. Now you see what I do now. I want to change my class. I change my class into a simple one. I don't bother about the type. So I change my class to a simple class. No more type T. No more this dot T equal to T. I don't need this one. And for the mutator method, I only need to update the character. A very simple class. And then for this one, I only print out character is. I throw away this one. I throw away string dot the value key. So now my printing is very simple. So the moment I enter a character, now I can construct an object of my character. So I can say my character MC is equal to new my character of CH. So now the last one we don't need the already. So if you look at the runtime first, so version number 2, and Java version number 2. So you just enter whatever character, no further action, right? No further action. Now we want to provide the further analysis. So next we do further analysis. Now I have 3 different types. I can use the switcher statement. I can say switcher of T, case letter. Now, letter, digit, and other are enum type. When you use it as the case label, you don't have to say type dot the letter. You can just simply specify the word letter, right? But if this is on the right hand side of the colon, you need to do some explicit specification. Type dot the letter. But for the case label, you don't have to. So now on the right hand side, I can say if CH is greater or equal to uppercase A and CH is smaller or equal to uppercase letter Z. Now I system dot out dot print line. It is an uppercase. Else I system dot out dot print line. It is a lowercase. I close, followed by a break. Now, if this is a digit, as usual, I can use the switcher statement. No, I can define a variable n in n. Now over here, I can say n is equal to ch minus character 0. Now I can use the switcher statement. I can say switcher of n percentage 2. If this is the case 0, I system dot out dot print line. It is even, an even digit, right? Followed by a break. Now default. So I system dot out dot print line. It is off. Okay. Now final case default. So default, okay, to say the default case now for the default case we want to say switch of T. I work on the T. I don't have the, I still you have to use the CH because I don't have the space. So I can say case a space, I system dot out dot plain line, it is a space, followed by the break, default. So a system dot out dot plain line it is a non-space symbol. I close. Okay. So now you can see that for the first half of the design, we work on the if-else statement. For the second half of the design, we work on the switches. This one extra one. We work on the switcher statement. On the right-hand side of the case label, we can have any statement. For example, if-else statement. On the right-hand side of the label, we can have any statement, including the nested switcher statement. So similarly, on the right-hand side of the default case, we can also have the switcher statement. Now I save. I can say Java version number 2 and Java version number 2. So I will start with the Y, it is a lowercase. I will start with the B, it is an uppercase. I will start with the A, it is even. Oh, sorry. I made a mistake. I put the P first. Just now I constructed the object, I should print out the NC dot print info. I should print out the info first. So I save. Now I run it again. Java. So Y, you can see that the character is Y, it is a lowercase. So I print out the T is an uppercase. I print out, enter the 9 is an odd. I enter the 2, it is even. I enter $sign, it is a non-space symbol. I enter a space, it is a space. Now, I try to save as a version 2A. I save. I want to explain a little bit. What is a conditional expression? Suppose I have an int x equal to something, right? I will enter a value for x. I will enter a value for x. If I want to say if x is greater than 0, I want to say x plus equal 5. Else x plus equal 20. So suppose I have a simple, if-else statement. I say if x greater than 0, x plus equal 5. Else x plus equal 20. How to apply a conditional expression to a simple if-else statement? You can see that this statement can be written in one line. I can say x plus equal x greater than 0, a question mark, I say 5. Otherwise, 20. So you can see that I can use only one statement to denote the if-else statement, right? X plus equal, x greater than 0, 5. They to say x plus equal 5 if x greater than 0. Otherwise, x plus equal 20, right? Now, similarly, I can also have system dot out dot print line, I say x greater than 0, question mark, 5, colon, 20. So, what did I do inside? I enter to the print line method. I say if x greater than 0, I print out 5. Otherwise, I print out 20. After the question mark, you can only have simple statement. Why? You can only have simple statement. Otherwise, you print out the 20. So if this is the case, I can simplify that, right? I can simplify that. For this one, I can simplify that. Maybe I put a comment statement here. I commented this one. Right? I say for this, I can replace it by what? Just one statement. System dot out dot print line n percentage 2 equal 0, question mark. I say it is even, followed by a colon. I say it is odd. I close. So therefore you can see that instead of having so many statements to decide whether n is odd or even, I can just write down one statement to see whether n is odd or even. Right? Now, we can do the test first. I try to save. If I change to version 2A, not yet. I save. Now I Java version 2A. I Java version 2A. I enter 7, no problem. I enter 8, no problem. Right? Now we are in the row. For the last one, I can also use one conditional expression to replace this statement. I only need to have just one system dot out dot print line. I say system dot out dot print line x equal not x, ch equal a space, question mark. I say it is a space, followed by the colon. So the next one, I say it is a non-space. So if this is too long, you can always align in this manner. Close, you close. Right? So now I save. And Java 2A and a Java 2A. I just enter the percentage, no problem. I enter a space, no problem. Right? We are now in the row. I use my version number 2. Okay, I use my version number 2. I save as a version number 3. If you look the version number 2. Main method did a lot of things to test whether uppercase, to test whether digit, to test whether it's other symbol, for other symbol is it a space symbol as well. Too messy, the main method. Will that be okay that I construct an object, I display the info? No problem. Now you see what I do? I cut. Wait, I undo first. I have to cut up to here. So I cut. No, not here. I cut from here until the switch statement. I cut. Now, will that be better that I just call the print info tell me everything. I don't have to do this task inside the main method. I make my main method very simple. So, where shall I paste? I go up. I paste here. Now, I needed to declare a variable, say type P. Okay? I needed to display the type T. I save. If I change to version number 3, I save. Java version number 3. Oh, n is not defined. I declare a local variable n. Save. So Java number 3. Now Java number 3. So I do the usual testing. No problem. A space, a 5, a hex, and a T lowercase. Exactly the same as what I did just now. Now my main method is very neat. Main method just read a character, construct an object of my character, get the print info to display all the info. But now come to the question. Again, if you submit this program to me, I may also want to make a little bit of noise. Print info did so many things. To check a type, after that to check for uppercase, to check for digit, and to check for others. And all these tasks are independent. That was why I say that if you design a program, you will respect the indentation and the separation of each of the subtasks. Converting your program to some user-defined method are just some sort of cut and paste. You see my first cut. What did I do here? I cut. I want to define a method. Maybe I say other useful method. First, I want to define a private method. I say the return type is type. I want to get the type. I paste. I don't have to do anything. I declare a type key. After that, I return key. I have designed a user-defined method to check a character belong to what the data type. Now, if I go to the display, the print info method, I have a key is equal to get the type. So I ask someone inside the class to give me the type of the character. So I have the type. Now, if I continue, I save, I Java, sorry, I return T semicolon, I save, so no problem, exactly the same as exactly the same as what we did just now. Exactly the same as what we did just now. Now, if you say that the printer info is still very huge, we still have some other tasks. Now, suppose if you say that you also want to replace so I paste again. I define a method. It's a Boolean method. I say it's uppercase. I want to check whether a character is uppercase. So now I paste. And this method return true, else this one return false. Now, usually when we design a method, what is a good method? A good method is a method that receives something and returns something. But what about our method does not receive anything? Yeah, we got something inside the class, the ch. That was why we didn't pass the ch to the method, because ch was defined inside the class. We can access to the ch. And then how to apply that to the display info? So, display info only need to say, maybe I just say system dot out dot print line. I say is upper case question mark. So the method over here, I don't have to say is the uppercase equal true, because the moment you say it's the uppercase, means what? If this is true, you display it is an uppercase, right? So now I can say it is an uppercase, followed by the colon. It is a lowercase. I close, semicolon. Now I save. go to Java, and I Java, so I enter U uppercase. I run it again, E lowercase. Now, of course, a good method is a method other than doing everything by yourself. You can also get someone to do it for you. Just like you are in a company, you can get some of your helpers to buy food for you. You don't have to go to buy food. Right? Same thing inside this print info method. I go to ask someone else to give me a type. I go to ask someone else to tell me whether that character is it an uppercase. With this info, I don't see any detail inside the method. A method should do only one task. If this is a get a type, you return the type. You don't do any printing inside. Right? Over here, since this is the print info method, you only do all sorts of printing. But before you do the printing, you may want to get the other people to help you to tell you the information. So therefore, even though we are working on the object-oriented design, in the object-oriented design, we also want to put in the modular design inside. So the modular design rely on the method. So therefore, you can see that Java is not just an OO programming, right? So we also have a lot of modular design using user-defined method. And all the method defined inside the class should be instant method, non-static method. Unless the method defined in a class that consists of the main method, in that case, you can put in some static method inside if you wish to, right? If you wish to, okay? So this is, of course, if you say that, can I continue to do that? No problem. You can just cut and paste to define another method is even, whether the character is even, right? If this is even, you return true, otherwise you return false. You should not go somewhere to do the printing. You go to somewhere else to make the decision. And all the printing should be done inside the print info method. Means print info just organize every subtask. Someone give me this information, I use them to perform my task. So therefore, you can see that the moment you know more and more features, writing programs is quite fun, right? Of course, you need to know how to apply that in a design. Actually, with this example, lab number 4 is officially out. I will release it a bit later, right? Tonight, I prefer to enter to the next topic on the replication control structure, right? We take a short break. After the short break, I may want to spend about another half an hour